Hello everyone, and welcome back to CS 11737 Multilingual NLP. Today I'm going to talk about database strategies to low resource MT, specifically strategies that we call data augmentation. So in low resource machine translation, we have a number of data challenges. So machine translation of high resource languages with large parallel corpora gives us relatively good translations. However, machine translation of low-resource languages with small parallel corpora still doesn't work very well without some tricks. So to give a concrete example, this is a system that's trained with 5,000 sentence pairs on Azerbaijani and English. And we feed in the source, and as the translation, we get "so I'm going to became a lot of people," which is neither grammatical nor at all correct, given that the reference is my father was listening to BBC News on his small gray radio. So we've talked a little bit about multilingual training approaches. So in multilingual training approaches, we can basically train a model in a high resource language, other high resource language, and adapt it to training the low resource language or translating the low resource language. And we can also do joint training with a low resource language and high resource language parallel data by concatenating them together to get an MT system. However, both of these methods have some issues. So the first one is suboptimal lexical or syntactic sharing when the high resource language is different from the low resource language in vocabulary or syntax. And another issue is that these methods cannot trivially leverage monolingual data. So the methods that I'm going to be talking about in this particular set of slides or this particular class are going to be handling these problems. So data augmentation basically tries to take our available resources, such as direct parallel data between the language we want to translate and the target language, maybe a related high resource language, or maybe monolingual data in the target language or even source language. And from these, we want to create augmented data where some of this data may be naturally occurring low resource language and target language data, but other data may be pseudo-parallel data that does not necessarily, it's not necessarily correct. It can be automatically generated in some way. So the first and simplest method of data augmentation for machine translation is something called back-translation, where essentially we take target-side monolingual data and we translate it backwards into the language that we want to translate, the source language we want to translate. So the basic idea is that we first take our small parallel data to train a target language to source language system. We use this system to back translate a lot of target language data, giving us a low resource language and target language parallel corpus. And then we train a low resource language to target language data translation model using the large kind of pseudo parallel data on the top right and the small actual parallel data on the bottom left. So an important thing to think about when we consider why back translation may or may not work is that some degree of error in the source data is permissible. So what we really want is we really want clean target data that tells our model what kind of data it should be generating. However, if we have a little bit of noise in the source data, basically our model can learn to translate noisy data, or it can learn to translate clean data by having the stuff on the bottom left. And as long as the noisy data and the clean data are similar, or as long as the noisy data still reflects most of the information in the target side, we can still see very good gains. And this is a very effective method that lots and lots of people use in building state-of-the-art systems. So we mentioned that we do back translation, and the next question is, how do we generate translations to augment our data? So the standard way of generating translations in this case is using beam search, which we talked about last class. And basically beam search selects the highest scoring output. This will give us the highest quality parallel data or pseudo-parallel data that we can create, but it comes at the cost of having lower diversity, and it also potentially comes at the cost of data bias. So for example, to give an example of this data bias, if there are two very synonymous words that mean the same thing and one is more frequent than the other, a beam search-based system might select the more frequent choice over the less frequent choice all the time, and that would lead the model to not be able to translate the less frequent choice very well. So as an alternative, it has been proposed that we should be using sampling to generate the data. So what we do is we randomly sample from the back translation model, and we may even randomly sample a different sample every time, every epoch of training. So this would allow the model to cover lots of different ways of saying the same target sentence. This certainly gives lower overall quality of the back-translated data, but it gives higher diversity. And overall, sampling has been shown to be more effective in general in a wide variety of experiments. So one issue with back translation, or standard back translation anyway, is that it learns from a very small, low resource and target parallel data set. So another way of improving translation is basically by doing iterative back translation. And the way this works is first we train a system in the direction we actually want to translate. We train a low resource language to target system. Then we forward translate the low resource language to the target. Then we take this and our original data and we train a target to low resource language back translation system. And we use this system to back translate from the target to the low resource language. So now we have augmented data in the, we have augmented data also in the backwards direction that we can use to train the best possible back translation system for the output. And then finally, we take this better back translated data to train the final low resource to target language system. So this is also frequently used, and of course you could do more iterations of this if you really want, but usually just a single additional iteration is enough to get most of the gains that you'll see. So as I said, back translation is a very successful method. I would definitely suggest considering it if you're planning on doing translation tasks. However, back translation fails often in low resource languages or domains. So there's a couple of remedies to this. One remedy being using other high resource languages for training. Another remedy being combining with monolingual data. There's other varieties of combining with monolingual data, but we're just going to talk about the simplest variety in this class because we'll be talking about more complicated ones later. And also performing other varieties of role-based augmentation. So let's go through all of these different methods. So first I'm going to talk about how we can combine multilingual training with data augmentation. And there are several ways that I'm going to talk about here. So the first way is English to high resource language augmentation. So the problem is that in a low resource language or low resource domain, target to low resource language back translation might be of very low quality. So one idea is to also back translate into the high resource language. And the advantage of this is that this will give us more sentence pairs that we can train from. Also, if the high resource language and low resource language are related, we can do vocabulary sharing on the source side data. Also, if the high resource language is syntactically related, we can use the syntactic similarity to bootstrap upon. And of course, like all back translation, this improves the target side language model because we're giving it more target side data. So this is what it would look like. We take our target language data and we translate it into the high resource language. And just to give an example, if we're working with Azerbaijani, we might also have a high resource language Turkish, which is very similar to Azerbaijani, where our English to Azerbaijani system just completely fails. But the English-Turkish system works relatively well, and still Turkish might be similar enough to Azerbaijani to work. So we would like the Turkish, obviously, here. So that gives us this additional set of our back-translated data where we can translate into the high-resource language. So a second variety of method where we can use high-resource language is augmentation via pivoting. And so the problem is that the high-resource language target data that we're given might suffer from lack of lexical or syntactic overlap. So even if it's two very similar languages, of course some words are not going to be the same. So the idea is to translate existing high-resource language to target data to low-resource language data. So we have this data set here, and we translate from the high-resource language to the low-resource language. So luckily, because the high-resource language and the low-resource language are similar lexically or syntactically, we might be able to do quite a bit better than we would be doing if we just translated from English to the low-resource language, even if resources are somewhat scarce. I'm also going to be talking about some kind of more heuristic or rule-based methods later, and these heuristic methods might work particularly well in this setting. So this gives us an additional data source that we can use, of course, where we translate our high-resource language to the low-resource language. And then finally, we can do back translation by pivoting. So basically what we do is the target to high-resource language back-translated data that we mentioned before also suffers from lexical or syntactic mismatch. And so what we do is we translate from the target language to the high-resource language, then to the low-resource language. And this allows us to leverage the large amount of English monolingual data while still improving our accuracy. So here's a schematic right here, and an example. So this gives us now an additional way of generating data. So we translate from the target to the high-resource language and the high-resource language to the low-resource language, which gives us a large augmented data set, like I mentioned before in the data augmentation introduction slide. Okay, so this gives some examples of how we can use a high-resource language to improve translation accuracy through data augmentation. And the next thing that I'm going to talk about is monolingual data copying. So basically the problem is that in very low resource scenarios, back translation may help with the structure or the syntax of the translation, but it can completely fail at terminology. So for example, we might have a back translation model that generates a kind of natural looking sentence in the source. However, if we have any low resource translated terms, etc., these terms, essentially the back translation model might fail and it will never be able to learn how to translate them. So a really simple idea that almost so simple that it's surprising that it works whatsoever is we use the monolingual data as is on both the source and target side. And basically what this does, here's a schematic down here, is this helps us encourage the model not to drop words, number one. So basically if we have the source and it needs to translate into the target, thank you so much, it will ensure that all of the words in the input and the output will remain the same. And in addition, it helps translation of terms that are identical across languages. So for example, in English and other languages that are written in Roman script, it's quite common that some proper names, etc., will be the same, and this can help improve the translation accuracy of those. So notably, this is a good method not to use on its own per se, but to use in combination with a poor back translation system. And if you add both varieties of data together, this can help improve accuracy significantly. So in addition to this, I'd like to talk about some final heuristic augmentation strategies. in these heuristic augmentation strategies, basically the idea is that we don't have enough data to train a good back translation model. However, the kind of strategy of just adding English is a little bit too, or just adding the source data copied or target data copied is kind of too broad brush. So what we would like to do is we'd like to take whatever parallel data we have and translate it in a kind of intelligent way that allows us to still do a pretty good job of generating pseudo-parallel data. So one method to do this is dictionary-based augmentation. And basically the way this works is we find rare words in the source sentence. So these are words that we think could use augmentation. Then we use a language model, could be any variety of language model, to predict another word that could appear in the context. So basically, if we have my sister drives a car, it could be replaced with motorbike. My uncle sold his house, it could be replaced with motorbike. So these are plausible inputs, and a language model would probably give fairly reasonable probabilities to these. Then we could also have Alice waters the plant. Here, replacing motorbike would not be a good idea because it's semantically strange. And John bought 2 shirts. In motorbike, this would also be strange because of syntax. So we hope that essentially by using a language model to calculate the probability of the output, this would help us filter out these kind of strange inputs on the input side. We then take this and we replace this word itself and a word in the target sentence that is aligned to the source word. And we use a translation dictionary with, for example, motorbike and whatever its equivalent is in the target language we would like to translate, and replace them in both the source and target sentences. So this is good for a number of reasons. The first reason is that actually, even in very low resource scenarios, it's still quite common that we have pretty extensive dictionaries. So, linguists or just language learning dictionaries or resources very often will create dictionaries, and we can just use them as is. We can also kind of learn these dictionaries directly from data. So I'll talk about how we can do so in a second. So how do we either learn dictionaries or find aligned words in the source and target languages? So basically, there's a task of word alignment. And so word alignment used to be kind of a really fundamental element of learning our models before neural machine translation. But now with neural machine translation, it's not used quite as widely. But basically, the idea is that we automatically find alignments between the source and the target words in a particular sentence, and we can do this for dictionary learning, analysis, supervision of attention, like I talked about last time, etc. So there's a number of ways to do this, and traditionally, as I mentioned, this was done before neural machine translation, so there are traditional symbolic methods. And the way these work is they basically learn a word-based translation model that learns the probability of translating each word into another word in an unsupervised fashion using something called the EM algorithm, which you may or may not be familiar with. The details aren't really important. And I'm not going to go very much into the details of how these alignment algorithms work. I'd be very happy to discuss them with people in the class who are interested. But for most practical purposes, you can know that there are some tools that allow you to do this. And one example is Giza++. This is a pretty powerful tool that does pretty well over a variety of languages in getting these alignments. And another tool is called FastAlign, and essentially FastAlign is a very fast version of these sorts of word alignment algorithms that works quite well for similar languages, but often won't work quite as well for different languages or other settings. So you can use this if you want something that's very fast and easy to use out of the box. In addition, there's recently been some neural methods to perform word alignment, and these methods essentially use models like multilingual BERT, which I talked about previously, or simply neural machine translation models, and they find words with similar embeddings in the source and target outputs. And one example of this would be the SimAlign toolkit, if you want to try one of these out as well. Okay, so this word alignment can be used to learn translation dictionaries. It can be used to decide which words to swap in the source and target sentences. There are even simpler methods of word-by-word data augmentation, and these are used in a variety of things. They're used in regular data augmentation if you don't have enough data to train a reasonable training model, reasonable back-translation model, and they're also used in unsupervised translation, which we're going to be talking about in a few classes. But anyway, the idea is basically that we learn a word-by-word dictionary or use one that we already have and translate each word one by one. And in this example from French to English augmentation, you can see that actually if you just do a word-by-word translation, this can work in some cases. So essentially, if we take this French and translate it word by word into English, we get a perfectly natural English sentence. However, of course, most languages aren't as similar as French and English. So if we took a Japanese sentence with the equivalent meaning, we might get something like, I the new car bought, which is not a great translation, of course. So how do we handle this problem? One way we can do this is word-by-word augmentation with reordering or other resolving of syntactic differences between the two languages. So as I said, the problem is that source-target word order can differ significantly in methods. So the solution is essentially to do reordering according to grammatical rules and follow a word-by-word translation to create the pseudo-parallel data. So essentially we have English here, and if we were doing English to Japanese augmentation, if we translated English word-by-word into Japanese, we get a similarly difficult or problematic translation. And what we can do instead is we can use some very simple syntactic rules that basically take bought and move it to the end of the sentence because it's kind of the head of its corresponding phrase. And we can also add basically grammatical markers after the object or the subject of the sentence. And these rules are specifically designed because I know, for example, that Japanese is a head final language where we want to move the head to the end of the sentence. I also know that it has grammatical case marking through morphology, or case markers. And so we should be marking each of these for the subject and the object. And so if you were a linguist, you could write a linguist that knows about the target language, you could write rules that essentially allow you to do this, and this can be quite effective. Additionally, one thing this is a paper by one of my students, Chunting, and one of the things we found in this paper was that you could apply exactly the same rules that were devised for Japanese to other languages with similar structures to Japanese. So these could be applied as is to Uyghur, which is another language with a similar syntax. Okay. So we had a little bit of a short video today, but I'd like to move on to the in-class assignment. And basically the in-class assignment is to read one of the cited papers on heuristic data augmentation methods. So you could read data augmentation for low resource neural machine translation or handling syntactic divergence in low resource translation. And I'd like people to try to think of how it would work for one of the languages you're familiar with. Are there any potential hurdles of applying such a method? And are there any improvements that you could think of? So thank you very much, and that is all I have for today.